Hi, I'm Phil. It's been a little while since my last video. So I've been down with COVID-19 and trying to recover. And I'm going to change themes. And instead of looking at uh, STEM topics for junior students, because I'm doing less of that now that I no longer do topics for CSIRO or Parramatta. Both of those have given me up. I'm now working and paying attention to the senior students. And one of the best topics and projects to work on are Raspberry Pi topics. And I haven't done those for quite some time. So I'm updating my Raspberry Pi background. So let's have a look at what we're doing. The Raspberry Pi Model 5 is the one that I'm focusing on. And I'm going to look at extensions such as adding an internal 1 terabyte SSD solid state drive, an active cooler, and some AI support. And I'm also going to have a look at some legacy to see if I can still support my older models, including the Model 3, and I'm going to focus on the Grove hat and the Python library. We won't do this all in the one video, but if you actually look at the benchmarks on the latest Raspberry Pi camera, or the latest Raspberry Pi Model 5, it's significantly improved, almost double that of the previous model. So we're getting better at performance, and it's becoming almost like a desktop computer. So if you look at all the specs, you can see that it not only supports a good CPU, but it also has a GPU to help with the graphics. And the one I've got the 8 GB RAM model. So what extra has been done? Well, that's what I want to do. I want to explore to see what's new and revive my knowledge of the Raspberry Pi. So if you want to go back to your Raspberry Pi, if you're not sure of which version, you can always use this command on the Raspberry Pi terminal. And the other thing I'm interested in later on, we'll have a look at the camera. And it has changed depending on the operating system. I'm going to focus more on the latest operating system called Buster. But you just have to remember that some of the commands, such as the camera, have changed. So I'll have a look at some of the projects. I was going to have a look at the Grove devices using the Grove hat. And there are two ways of doing that. You can either use Python, and here's the Grove hat. So the Grove hat sits on top of the Raspberry Pi. And you can see it's got quite a number of devices that can be added. And it worked very well with Python on a Model 3. So we got that to work quite well and testing a number of Grove modules. And also on Grove 4. But it didn't work so well on Raspberry Pi 5. And I'm trying to get some help from Seed Studio, and I'm having some difficulty in creating a virtual environment for the Raspberry Pi Grove library. Anyway, I had similar problems with Node-RED, but recently I discovered that there is a version, and even though I didn't have success at all with Model 3 or 4, I could backtrack and reinstall the latest nodes for Node-RED, and they'd all work. So the one that I'm looking at today, let's have a look at the project. It's on Model 5, and this is what the desktop looks like. So you can see the Raspberry Pi is actually sitting right on the bottom layer, and on the top layer we've got all the Grove devices on a Grove hat. And these are some of the Grove devices that I'm testing. They all worked, which was really good. I'm testing the camera, and the objective of this exercise is to test the Seed Studio library. It's actually the Node-RED, not the Python library, on 9 Grove modules. And I also want to establish a development environment on Raspberry Pi 5 for other projects where this becomes the foundation or the framework for all of these projects. And they'll all use Grove devices, and it's for senior STEM students. Now, the important thing here is you've got to get the version right. So while it's Raspberry Pi 5 and we're using the latest operating system called Bookworm, we also have to get the right versions of Node-RED installed and the right versions of the nodes. I'm also testing some new hardware. So we're testing Grove devices, the LCD, the RGB backlight. And the thing about this one is that it needs a 5-volt supply, but the Raspberry Pi through the Grove hat doesn't supply that. So you've got to pick that up from either pin number 2 or 4. I'll be using Grove push button, relay ultrasonic, the angular rotary sensor, and I'll also test the Grove pulse width modulation 16-channel unit, and that's for servo control. And environmental units, I'll be testing the BME 280 for temperature, pressure, and humidity, but I'll also test the temperature and humidity, both the Pro sensor and the ordinary sensor. So that Pro should go out of DHT11. I'll be using Grove wrappers and a number of Grove cables. Later, I'll compare the performance on extra storage modules. So at the moment, we've got this configuration connected to a Samsung solid state drive, 1 terabyte, and I'm just checking the performance on that. Communications wise, I'm connected to both Ethernet and Wi-Fi, but my VNC connection is on Ethernet. So the software, I'm using Bookworm, and for the actual code, I'm using a number of devices, but they're all based on Node-RED. So the actual code, well, I might have a look at the latest one on that one, see if we can find it. Here it is. We're using this test series of flows on Node-RED. And we might actually go across and have a look at those in detail. Some of them you can see here. So for the analog ones, I'm using the Grove sound, also the air quality, and I'm getting debug information onto this serial port. I'm using the Grove ultrasonics, and for the display, the LCD RGB backlight. And here are the other nodes. So you can see these are all the nodes on Grove. Also want to test a couple of I2C. One of them I've mentioned already is the RGB LCD, the digital light. And we're going to add another one to that, would be the pulse width modulation servo system. So we might move across and have a look at those nodes. We'll just bring them up now. So here we've got VNC working, and I've got all of this going on to my Chrome browser on the PC. So we might go across. Here's my program, and across each line here, you've got a single flow. So the flow starts off from the left and moves to the right. So if we wanted information on our ultrasonic rangefinder, we just simply press the button here, and I'll get rid of all my previous results and just press those now. So you can see here, that's the, I'm going to change the distance to the ultrasonic rangefinder, and here that's much closer, and that'll be a bit further away. So we've got 23 centimeters here, and that result is occurring on the right here. Moving down, we've got the standard Node-RED module for Raspberry Pi, and it's actually the push button. So if I press the push button, it will go to 1 and back to 0. So you can see the result there. And we've got the Grove sound sensor. And if I press on that one, we'll get a measurement. Now, I actually have the rotary angle sensor connected to that. And here I've got the rotary angle sensor connected to the RGB backlight. And I'm going to put a message, hello world, onto my RGB. So just testing a couple of these other ones. Right on the bottom, we've got a relay. And if I want to set the relay, I'll turn it on. And that one doesn't work. But the equivalent native Raspberry Pi Node-RED node, I can get that to turn on the relay or turn it off. So the bottom ones work, but these ones don't. And I felt, what information from the Grove BME 280? I just simply press that button, and the information comes up on the debug screen, and it tells me the temperature is 17.63, gives me the humidity of 56, and the pressure 996. And that's Node-RED on the Raspberry Pi, and I'm examining all that using VNC on my Windows computer. So we might go back, and later on I'm going to have a look at perhaps just looking at the performance. I got 7 of the 9 modules. What worked? Well, all the analog, the digital, and analog all worked. What didn't work, so what also worked was the LCD screen and the environmental. They all worked. What didn't work was the, I tried the Grove digital light. I only got the Grove relay. The Node-RED Grove nodes didn't work, but I could use the native digital control for Raspberry Pi from 1 to 0, and that was able to toggle the relay. And I didn't get the Grove pulse width modulation node to work either. So I was able to establish a reasonable development environment for the Raspberry Pi and using Grove modules. And here are some of the projects that I'm proposing. One would be looking at environmental parameters such as temperature, humidity, and pressure, and turning my Raspberry Pi into a data logger for that and air quality. So any analog measurement can be used on this framework. I could do a fan control, but the Grove fan won't work. The only way to do that would be to use the relay with a USB fan. I could do a project with breaking the light beam, because we do have the light sensor working, and I could use that to measure speed. I could also do a PID control on a heater using the pot as setting the temperature set point. And I could do camera control where the ultrasonic rangefinder can trigger the camera, and I could do a series of time-lapse sequences of photos. So that went reasonably well. I need to purchase some extra Grove components so that I can readily do these projects in the future. I guess one thing that's missing and not even mentioned is that on the Grove hat, there is a UART port, and there's no Grove connections, or there's no Grove Node-RED support for that. Okay, so for the references, now you have to, part of that version control, you have to use the Grove base hat, particularly this version. All the previous versions won't work. So this was updated after, would be after the release of the Bookworm operating system. And here are some of the other references. And if you're interested in getting the Grove modules, you can get those from Seed Studio. Okay, so that's it from me. In the next video, I'll have a look at memory and how I went with fitting the SSD 1 terabyte drive to the Raspberry Pi. And I'll also look at how that compares with SSD drive, the same rating, but using a USB connection. I'll look at the AI kit for Raspberry Pi. I'll do a camera test with a number of cameras and compare those. And I'll fit the Raspberry Pi Model 5 into a case. And the case will look like this one. So the future videos will show other projects for the Raspberry Pi Model 5. So stay tuned for a desktop demonstration. This is the upgraded Raspberry Pi computer. It's a Model 5, 8 gigabyte RAM Raspberry Pi, and it's on the bottom layer here, so you can't quite see it. But sitting on top is a active cooler, and on top of that we've got the Grove hat, and you can see there are quite a number of connections from the Grove hat to all these Grove devices over here. So I'm testing them all. So what we also have is a connection from the camera, and it took me a while to work out. I thought I couldn't connect the camera, but it turns out that it uses a different cable. So the Raspberry Pi Zero cable is the one that I'm using to the camera. And in addition to these Grove modules, I also have a LCD RGB backlight. So that's another, and that's inside a 3D printed unit. So it says the message, "Hello world," and all of that software is driven by Node-RED. So we have nodes for each of the hardware devices. So these Grove devices, we've got right on the left a ultrasonics rangefinder, DHT11. So we've got a relay next to that, and a angle rotary sensor, which is a potentiometer. We have a BME 280. Next to that, a push button and a air quality sensor over here. So there's our air quality sensor. And that's everything for the project to test Grove Hat and Grove devices on Raspberry Pi.